Good morning, dear students. So today we are going to start a new session of matrices. Actually, I've done the same chapter in other language. Okay, so I'm just doing this series in English language now for few people who cannot understand Hindi or the other languages. Okay, so matrices. Let us, without wasting a minute, let us directly go into the concept. So first thing that comes into your mind is what is matrix, right? This is the plural, this is singular. So what is a matrix? That is nothing but a rectangular arrangement. Okay, I will not tell you the definitions because you are going to get them in the textbook as well. So I'll just tell you a normal way. Rectangular arrangement. So what you are going to do, you're taking certain, they can be numbers, they can be alphabet, no problem. Okay, so usually we take numbers, they can be real numbers, they can be complex numbers as well. So if you are taking real numbers, that becomes a real matrix. If you are taking complex numbers, then that becomes a complex matrix. Okay, so here I am just taking a real matrix because at the basic level you do not consider complex numbers. When you go to the higher level, you consider complex matrices as well. Okay, so see these things. This is a rectangular arrangement. Okay, why rectangle? Because it, see the way we have arranged these numbers, it appears as a rectangle. See, it is like rectangle, right? So that is the reason rectangular arrangement of certain numbers, they can be real or complex, is nothing but a matrix. Okay, so in matrix there comes one more concept, that is row, and one more column. Okay, these two concepts, most of the students even don't know this thing, means they feel confusion or they are not aware of this thing. Then you can even get it here. See, row means are this way, in the sense the things, the entries which are written in this way, entries in the sense whatever I have taken inside these brackets. Okay, these things are known as elements or entries of a matrix. Okay, of any particular matrix, we call these are the entries of a matrix or elements of a matrix. So rows in the sense which are written in horizontal way, column in the sense which are written in the vertical way. So here 1 2 3 which is written in the horizontal way, this way. Okay, so that comprises first row. Then 4 5 6, this comprises second row. Okay, and I said column or vertical, right? So this one 1 4 1 4, this is the first column. Okay, I have written in explanation form sorry, expanded form. If you want, you can write like C1. It is just for your understanding. Okay, C2 means which one? Second column. C3 is 3 6. Okay, so this is first column, second column, third column. So this is the concept of row and column. So next we shall move on to one more concept, that is known as order of a matrix, right? So order of matrix so usually we represent that as m cross n or m by n, m cross n. Okay, not an issue. So how we are going to write this thing is, any matrix, suppose I take the same matrix 1 2 3 4 5 6, then what is the order of this matrix? If I say matrix, let me just represent it as matrix A. Okay, so what is the order of this matrix? Then you have to say number of rows. These are number of rows. What about n? This is number of columns. Okay, so first you have to write number of rows, that is m means 1 2 rows, right? R1 R2 when it comes to column, C1 C2 C3, right? So number of rows are 2, cross or by number of columns 1 2 3. So the order of this particular matrix which is given to us is 2 by 3 or 2 cross 3. Okay, so this is one more basic concept that you must be knowing. Then let's just move on to types of matrices. See, I have just represented these three numbers. Now if we take particular entries, then what the particular matrix is known as. Okay, it is known as with some unique name. So let us just go with types of matrices to understand the various types of matrices. So types of matrices, the first one that we are going to learn is a row matrix. What do you mean by row matrix? Any matrix where there is only a single row. Number of columns can be more than 1, but the row is always 1. So how do you represent? Say 1, 2, 3, 4, 5. You can write any number of columns. Okay, but the row is this one, R1 only. What about columns? C1, C2, C3, C4, C5. There are 5 columns. Okay, so what is the order of this matrix? It is number. What is the order? I said number of rows cross number of columns. So number of rows 1, number of columns 5, right? Because number of rows is always 1 in row matrix. That is the reason the general order we write for this one is 1 cross n. N can be any number. Okay, so that depends on which example you are taking. This is row matrix. Similarly, we have one more thing, that is column matrix. You can easily guess from the above definition that here number of rows can be any. Okay, any number of rows can be written, but number of columns is always 1. Okay, so how you are going to write is 1, 2, 3. Suppose I write like this. Number of rows are 1, or 2, or 3. This is C1. Okay, so what? How many number of rows? 3 cross 1. So this is the matrix of order 3 cross 1. Here this 1 is constant always, so that is why we have written this order. Okay, so then comes one more matrix, 0 matrix. So by the name itself you can guess what I actually mean. See, 0, this is matrix. You are going to write matrix in which all the entries are 0. Alright, so this is also known as null matrix in mathematics or anywhere. Null in the sense nothing, right? So 0 matrix, it is represented as O is equal to, you write any number of entries. You can write, I have just taken 4, it is 2 cross 2 matrix. Okay, so 4 zeros. If I take some more, 0 is equal to 0, 0, 0, 0. I can take like this as well. Okay, this is 1, 2, 3 cross 2. So 0 matrix in the sense the matrix in which all the elements are 0. That is known as 0 matrix. Then comes the next type of matrix, which is the most important, that is a square matrix. Okay, so we're just having one more matrix, it is square matrix. Okay, so what is a square matrix? It is a matrix in which number of rows is equal to number of columns. If I write the order of any matrix just like this or like this, that value of m and n must be equal. Then that becomes a square matrix. Let me just explain you with an example. So m is equal to n. I just write 2 rows, okay, and 2 columns, 1, 2, 1, 2. Okay, see R1, R2, C1, C2. So what's the order of this matrix is 2 cross 2. Okay, so the matrix in which number of rows is equal to number of columns is known as square matrix. Okay, the elements can be the entries which you are taking can be anything. It's your wish, you can take any number. Okay, then that becomes a square matrix. But in a square matrix, okay, if you take particular entries, then that is known as with particular name. Let us just go with those also. But before that, let me tell you one more concept. So in a square matrix, okay, here if I take in 1, 2, 3, 3 columns, then I have to take 3 rows. Okay, so in a square matrix, these particular elements which are in this way, okay, these elements, they are known as, okay, I'll just write it here for your convenience, diagonal elements. They are known as diagonal elements, and this particular thing, okay, this is called principal diagonal. Also they can be called as principal diagonal elements as well. If you're taking other elements, that will be off diagonal elements. Okay, so why I said the concept of diagonal elements is because you can understand the next type of matrix by using this. Okay, so the next type of matrix, which is also a square matrix but with particular condition, let us just try to know that as well. So that is diagonal matrix. So what is a diagonal matrix? It's a square matrix, okay, It's a square matrix. But what is the condition in this square matrix is that the elements other than diagonal elements, okay, so you can say like diagonal elements are non-zero, okay, but the elements other than the diagonal are all, okay, let me just write it, elements other than diagonal elements, okay, are 0. So what do you mean by this? See, if I write a square matrix 1 2 3 4 5 6 7 8 9, then these diagonal elements are non-zero. This condition is satisfied, but all the other elements, see, elements other than elements, or you can take entries as well, no problem, entries other than diagonal elements are 0, right? So this is diagonal, these are diagonal elements, so other than that these are 0 0 0 0 0 0 0. So this is a 3 cross 3 square matrix. So here this becomes a diagonal matrix when the diagonal elements are non-zero and all the other elements are 0. If I write 2 cross 2 matrix, then diagonal elements are non-zero, other elements are 0. Simple, okay. If I write 4 cross 4 matrix, just have a notice: 1 0 0 0 2 0 0 0 0 3 0 0 0 0 4. So the diagonal elements here, okay, they are non-zero and all the other elements are, all the other entries are 0. So this is 4 cross 4, okay. So this is known as diagonal matrix, square matrix in which these conditions must satisfy, okay. Now diagonal matrix, in that you take one more consider one more condition, that is these diagonal elements are all same. If I take 2, it is 2 2 2 2, okay. So then that particular matrix is known as one more name, that is scalar matrix. So what is a scalar matrix? What is a scalar matrix? It is actually a diagonal matrix, okay. What do you mean by diagonal matrix? You have learnt it. So all the other elements other than diagonal elements must be 0. But here the condition is that the diagonal elements ai, if I take, is equal to one particular number. They should be always equal to one particular number, in the sense they should all be always equal. Suppose I take the same example, 4 cross 4 matrix. If I write 2 0 0 0 2 0 0 0 0 3 0 0 0 0 2. This is not a scalar matrix, as because the diagonal elements are not same. 3 is there, which is a different value. So if I take this as 2, then this becomes a scalar matrix. I hope you have got this point. Scalar matrix in the sense the matrix, the diagonal matrix in which all the diagonal elements are same, okay. So in that you do not consider k is not equal to 1. K should not be equal to 1. Because why? Because you will come to know in next definition that if diagonal elements are equal to 1, okay, scalar matrix in which diagonal elements are equal to 1 is known as unit matrix, okay. There is one more name, unit matrix or identity matrix. Identity matrix. So that is the reason you do not take k is equal. Even if you take, that's not a mistake, okay. But because we already have one standard name for this matrix where k is equal to 1, we do not include this here, okay. You can take any number of values. So this is unit matrix. Next you have one more matrix. Let us just go with that as well. So that is known as upper triangular matrix. So it means that it is also a square matrix actually, where what happens is that, suppose this is one particular matrix, square matrix, right? M is equal to n, so m cross m, okay. So here the diagonal elements and the above elements, they form upper triangle, in the sense all the entries here, okay, are non-zero, but the elements below are all 0. So then that is known as upper triangular matrix. What actually happens here is that, let me just tell you an example: 1 2 3 0 4 5 0 0 6. See, the elements diagonal and the other elements, they are triangle. All the elements below the diagonal are 0. then that is known as upper triangular matrix. Now you can guess the other matrix definition as well. Lower triangular matrix, it is just has upper triangular, opposite to it. Okay, so what here in the matrix, the elements are in the lower triangular. Here there are non-zero elements, here the elements are 0. Okay, so let me take the same example. 1 0 0 2 3 0 4 5 6. Okay, so see, this is forming a triangle. In the sense, the elements below the diagonal elements are non-zero and above are 0. That is known as lower triangular. And if I take upper triangular and lower triangular combined, then that is known as triangular matrix, which is nothing but again diagonal matrix. Right, upper triangular and lower triangular when combined together forms a diagonal matrix itself, right? Because upper triangular means the elements below this must be 0, diagonal must be 0. Lower triangular means the elements above the diagonal elements must be 0. And when you take triangular, it is both upper and lower. So that means the elements below the diagonal and above the diagonal both are 0. Then therefore the only diagonal elements are left. That is nothing but our standard definition, diagonal matrix. Okay, so next we have, let us go with one more definition, that is we have submatrix. SUB, submatrix. I hope you are all familiar with subset, right? So if I take a big set A, B, C, D, something like this, and if I take some part only B, C, then this particular thing is the subset of this. Same applies to the matrices as well. So submatrix is nothing but a matrix that is obtained from a standard matrix. Suppose I have here a matrix 1 2 3 4 5 6 7 8 9. Okay, so if I get one matrix from this one by eliminating one row and one column, okay, it is not standard definition that you should eliminate one column only. You can eliminate any number of columns and any number of rows, but when you eliminate, you obtain one certain, the other matrix, right? Suppose here I am obtaining 5 6 8 9. So this becomes submatrix of this matrix A. Okay, so B is the submatrix of A. Then you have one more concept that is known as principal submatrix. When do you call it as principal submatrix? What is the difference? You must be knowing this thing as well. Submatrix in the sense you can eliminate any number of rows and any number of columns to obtain a matrix which may be square, which may not be a square matrix. Okay, here coincidentally I have obtained a square matrix. Let me take one more example of 4 cross 4 matrix. Okay, so I have this matrix. What is the order of this matrix? Is that 1 2 3. 1 2 3 4. Okay, 3 cross 4. So here this is matrix A. Then if I eliminate one row and one column, I am going to get matrix which is 7 7 7 0 3 4. Okay, so what is the order of this? 1 2 1 2 3. So this is the submatrix of this matrix. But if I eliminate the number of rows and number of columns in such a way that the submatrix that I obtain is a square matrix. Let me just illustrate this with an example. You eliminate one row and you eliminate two columns. Then the submatrix that you are getting is 7 7 3 4. Okay, 7 7 3 4. So this is a principal submatrix. I hope you have got the difference. Submatrix means you can obtain a matrix by eliminating any number of rows and any number of columns. That matrix may be square matrix, may not be the square matrix. Okay, may not be the square submatrix. Okay, so but the submatrix which you obtain by eliminating number of rows and number of columns is a square matrix. You have obtained square submatrix, then that particular is known as principal submatrix. Okay, I hope you have got this thing. Then let us go with one more concept, that is equality of matrices. Suppose I take two matrices, A is equal to A, B and 1, 2. Okay, I have just taken general example. B is equal to, I am taking C, D, 1, 2. Okay, and now to call these two matrices A is equal to B. If I am calling this A is equal to B, that simply implies that A must be equal to C. Strictly implies that A must be equal to C, B must be equal to D. It simply means that if you want to call any matrix equal to any other matrix, then the corresponding elements must be equal. What do you mean by corresponding elements? Corresponding element in the sense, if you are taking first element of a matrix then and comparing with the other matrix, then you must compare to the first element of the other matrix. If you are taking second element, you must compare it with the second element itself. You cannot compare B is equal to fourth element. Okay, so that is why if you have to call any two matrices as equal, the corresponding elements must be equal. Okay, so this is just simple concept. Next, let us come to addition of the matrices. So addition, I hope you know the normal addition, right? Addition of the simple thing applies here as well. Okay, so addition, if I tell you 2 plus 3, what do you say? It's 5, right? The same way, if I'm telling A plus B, two matrices, if I take 1, 2, 3, 4 is matrix A plus 1, 2, 5, 7 is the other matrix, then add these two matrices. Okay, if I call this, you have to add these two matrices, then what you are going to take is that you are again going to add corresponding element, that is the first element with the first element. 2 plus 2, 4, 5, 3, 8, 4, 7, 4, 7 is 11, right? Here you can observe one more condition, that in order to add any two matrices, they must be of same order. Always remember this condition. This condition is known as confirmability of addition of matrices. Okay, whether two matrices are confirmed for addition or not, it depends on the order of those two matrices. Okay, so these two are 2 cross 2, 2 cross 2, and the resultant obtained is also 2 cross 2. Okay, so then this, if they are of same order, then they are confirmed to add, or else you cannot add. Why? Let me take this example. See, 1, 2, 3, 4, 5, 6. What's the order of this? 2 rows, 3 columns, and I take this matrix 1, 2, 5, 7. Okay, so this is 2 cross 2. Now corresponding elements, if you are going to add, this column cannot be added. Why? Because there is no third column, right? So that is the reason two matrices, when we are adding them, when we are adding the two matrices, the order of those two must be same. Okay, so then similar way, if we go with multiplication of a matrix by scalar, multiplication by a scalar. What do you mean by scalar? Is nothing but it is a constant number. It can be 2, it can be 3, it can be 4, but it's a number. Okay, that is known as scalar. So you're going to multiply matrix. Suppose I say 2A, then the whole, if 1, 2, 3, 4 is matrix A, then multiply 2 to every element. Okay, then 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8. This is matrix multiplication by scalar. Then let me tell you the same concept, a concept in the same matrix itself, that is trace of a matrix. That is always trace of a square matrix. Okay, so what does this mean is that adding the diagonal elements. That's it. Suppose trace of this matrix, if I tell you 8 only diagonal elements, 8 plus 2 is equal to, so we'll denote it as TR of A is equal to 10. TR of A is equal to 10. Okay, so trace of A is equal to 10. If I take some other matrix, suppose I take this matrix, then 1 plus 7 is equal to 8. So TR of that particular matrix is B, then it is 8. Okay, so that is known as trace of matrix, which is nothing but adding the diagonal elements. So I hope we are done with the okay, there are some more concepts, that is transpose of the matrix and other concepts. I think the video will be too long. Okay, let me just try to continue this thing. Let me explain it a bit faster. If I have a matrix A 1 2 3 4, then the transpose of this matrix is nothing but write the rows as columns. Okay, so 1 2 you write it as 1 2, 3 4 write it as column, So this is known as A transpose. So transpose is nothing but you're going to change the rows and columns, interchanging of the rows and columns. That process is known as transposition. Okay, but when you transpose that particular is A transpose. It is denoted as A power T, or you can write simply A dash, no problem. Okay, so when you find any particular matrix where the matrix and its transpose are equal, then that matrix has a particular name that is known as symmetric matrix. So let us just take an example. 1 6 7 6 5 2 7 2 3. So this is a matrix. You just do the transpose of this matrix by yourself and you will obtain that is again equal to the same matrix. Okay, so that is known as symmetric matrix. Next, let us come to the skew symmetric matrix. Very simple. See, symmetric matrix, very simple. Diagonal elements can be anything, but these are equal. Okay, mirror images. Okay, then when you come to skew symmetric matrix, you are going to write diagonal elements must be 0. This is the condition, and all the other numbers are mirror, especially mirror elements. Okay, there you are taking mirror elements. They are equal but with opposite sign. If I take 3 here, it must be -3. If I take +6, it should be -6. So when you do the transpose of this matrix, it is equal to minus of particular given matrix. Okay, so when this condition is satisfied, this is known as skew symmetric matrix. Okay, I hope you got this point. If you have not got, I'll explain it once again. Okay, just drop a comment, I'll explain this. It's very simple actually. Fine, then there's this. Let's end up with one concept, last concept, that is product of matrices. How do you multiply two matrices is also a very important concept. See, when you're taking any matrix, suppose I take 1 2 3 4 and have one more matrix 1 2 3 4 5 6. See, for addition I said that the order must be same. Then for multiplication, what is the condition is that number of, see here 2 cross 2 and here 2 cross 3, right? So 2 cross 2. Here number of columns of the first matrix must be equal to number of rows. You just write the order. If this is equal, you write m cross n. Here it should be n cross p. Then the answer that you obtained, that matrix will have the order m cross p. Always remember this condition. So how you're going to multiply is an important thing. Let me just explain it. You have to multiply this first row with the first column. Simple. The same first row with the second column. The same first row with the third column. Okay, so how do you do that? 1 into 1 plus 2 into 4, right? Then you are going to get the first element of the resultant matrix, which will have m cross p order, in the sense 2 cross 3. Okay, so next, first row with the second column, that is 1 into 2 plus 2 into 5. Similarly, 1 into 3 plus 2 into 6. Next, second row elements with the first column, second row elements with the second column, second row elements with the third column, just as you did the first row. So we'll write it as, I've just written them directly to save the time. Okay, so this is how you're going to write, and then what you're going to do is that you just write the total answer. 1 into 1 is 1 plus 4 to the 8 is 9. Similarly, you just solve by yourself, you'll get this answer, right? 19, 26 and 6 for 24. Okay, 33. So this is having the order 2 cross 3. So most important thing for matrix multiplication. So any two matrices can be multiplied only when the number of columns of the first matrix is equal to number of rows of the second matrix. This is the important condition which these matrices must satisfy. Then matrix multiplication is possible. Okay, so I think this is enough for today. We'll just sum up everything now. Okay, so we have learned about matrices, we have learned about types of matrices, right? So what is a matrix? Rectangular representation. Then you're having rows, you have the concept of column. Just please, if you have any doubt, please drop a comment. I'll just try to answer those things. Okay, next, let's just wrap up. We'll come with some other video soon. So this is enough for today. Thank you so much. God bless you.